Hi guys, welcome to Chem Archem. In previous videos, we seen series of esterification and lactonization reaction. In this video, we are going to see Corey-Nicolaou macrolactonization. Before moving to this video, please subscribe if you are new to this channel. In Corey-Nicolaou macrolactonization reaction, omega-hydroxy carboxylic acid can be converted into the corresponding lactone by two-step reaction sequence. In first step, omega-hydroxy carboxylic acid reacted with 2-pyridyl disulfide and triphenyl phosphine, which generates 2-pyridine thiol esters. In this 2-pyridine thiol ester, when we treated under suitable reaction temperature, which can be converted into the corresponding lactone as well as pyridine 2,1-thione as a byproduct. Before moving to this mechanism, I would like to give some important points about the Corey-Nicolaou macrolactonization reaction. This is the reaction for the synthesis of lactone from omega-hydroxy carboxylic acid. This particular reaction can be highly suitable for both base as well as acid-sensitive substrates containing omega-hydroxy carboxylic acid. This reaction needs very dilute reaction conditions, which favors the intramolecular esterification reaction, and lactones with ring sizes 7 to 48 have been successfully achieved by utilizing this strategy. However, the reaction rate strongly depends on the both ring size as well as functional group present in the omega-hydroxy carboxylic acid. So next we move on. What are the reagents needed for conduct this Corey-Nicolaou macrolactonization? There are two reagents are needed. One is 2,2-dipyridyl disulfide and another one is triphenyl phosphine. These both reagents are needed to prepare the 2-pyridine thiol esters. Next, we move on mechanism. In mechanism, in the first step, 2-pyridyl disulfide react with triphenyl phosphine. Here you see triphenyl phosphine phosphorus contains the lone pair of electron which attacks the one of the sulfur atom in the 2-pyridyl disulfide. Then followed by cleave the sulfur-sulfur bonds which lead to provide the 2-pyridyl thiolate ion as well as 2-pyridyl triphenyl thiophosphonium ion. Now 2-pyridyl thiolate ion react with omega-hydroxy carboxylic acid, which generates the corresponding 2-pyridyl thiol as well as omega-hydroxy carboxylate ion. Now this omega-hydroxy carboxylate ion react with 2-pyridyl triphenyl thiophosphonium ion. Now you look how that reaction works. Now this O negative charge comes in, this pi bonded electron attacks the phosphorus. Now resulting that phosphorus sulfur bond break down, which leads to provide this type of intermediate. Now this intermediate readily react together like this. Now you see pyridyl to thiolate ion attacks the carbonyl carbon. Now these electrons comes out and then followed by comes in, then followed by break of carbon oxygen bond, which leads to provide the triphenyl phosphine oxide as well as in this intermediate. So now you look in this intermediate, pyridyl nitrogen act as a template. So template means now pyridyl nitrogen helps to bring both hydroxy group as well as carbonyl group very close to each other. So this template helps to easy macrolactonization step. So for that reason, we can say this one acts as a template effect. So now this pyridyl nitrogen abstract the proton from alcohol, which leads to generate the corresponding alkoxide ion in the one N and another N pyridinium ion. Now that pyridinium ion readily forms the hydrogen bonds with the carbonyl carbon. So how this happened? Now you look, this carbon sulfur bond rotates to form this structure. Now this structure as well as this structure present in the equilibrium condition. So because of this hydrogen bonding effect, which makes that this carbonyl carbon as electron deficient, then quickly hydroxide ion attacks intramolecularly this particular carbonyl carbon. Now this bond moves towards to the here. Now this bonds breaks down, this electrons goes into the nitrogen, which provides this 8-member ring system along with tetrahedral intermediate. Now this predyl nitrogen abstract the proton from this alcohol. Now oxygen hydrogen bond breakdown, this electron moves in, then followed by kick off this predyl unit, which lead to generates the corresponding lactone as well as pyridine to 1-thione as a byproduct. So now we are going to see some of the examples. So this is the one of the example. This examples aromatic carboxylic acid, and in the another end contains the alcohol. When you subject under the Corey-Nicolaou condition, which generates a corresponding macrocyclic lactone. So this is the another example. This compounds contains primary alcohol as well as in another end has carboxylic acid. When you subject under Corey-Nicolaou condition, which generates the corresponding macrocyclic lactone. So this is one more example for preparation of macrocyclic lactone by using Corey-Nicolaou reaction condition. Sometimes the addition of silver salt is necessary in order to boost up the reaction. For example, when you add silver perchlorate, that helps to activate the predyl thioester, which found to be accelerate the reaction dramatically. So when you add the silver perchloride, that activate the predyl thioester like this. For example, when you generate the predyl thioester, which makes the complex with silver, so because of that complex formation, which makes this particular carbonyl carbon as a more electron deficient center, now this oxygen, this alcohol can readily react to form the lactones. Now this is one of the example for using silver salt for the macrocyclization step. In the first step, that generates the corresponding pyridyl thioester. In the next step, when we add the silver perchlorate salt, which makes the corresponding macrocyclic lactone product. Next, we move on alternative to 2-pyridyl disulfide. So there are several reagents are reported instead of 2-pyridyl disulfide. Here are some of the examples. First one, this reagent based on imidazole, and this reagent based on pyridine, and finally this reagent based on pyrimidine. So these all the reagents can be useful for this Corey-Nicolaou macrolactonization reaction. So this is the one of the example for using imidazole based disulfide under this Corey-Nicolaou reaction condition, which generates the corresponding macrocyclic lactone. So finally, we comes to the problems. When you get the free time, you just give a try to these Corey-Nicolaou macrolactonization problems. So finally, we come to the end of this video. If you like this video, please share to your friends. I hope most of them understand this concept. In next video, we'll see one more esterification. Until bye-bye.